Selamat siang, bagi yang sudah hadir mungkin bisa presensi terlebih dahulu, karena sebenarnya waktu 30 menit ini sekitar 20 menitan untuk, eee, persiapan ya dan registrasi dan presensi. Salam Prof. Siti Yaitun.
Selamatullah. Aina.
Ya,
Ya,
apa kabar Prof?
ya, apa khabar?
Ya, Alhamdulillah.
Sekejap saya tengah adjust.
Oh, ya, oke. It's okay.
Ini pukul berapa ambil gambar?
Maybe 5 minutes later, Prof.
Hmm.
We will opening this event first, and then maybe we can take a photo. Yeah, maybe around 5 or 8 minutes.
Okay.
But I inform Prof. Aslan at 2 p.m. But it's okay. We will take a photo again later, maybe for the end session or maybe during session.
Okay. Ini expected how many students?
We didn't define it, Prof. Yeah, I think it's already okay lah, because it's sometimes on only 30 or 40, but it's already 55.
Okay.
Yeah.
This is from...
We expect maybe only 50, but now it's already more than that, but it's okay. So
it's
it's
from one
okay.
class lah. One class.
Oh no, actually it's not replace a week in a class. Yeah, it is a public event. We encourage all students, yeah, to join this seminar.
Okay.
Yeah, actually this is the monthly event in our department, Prof.
Oh, I see. Okay.
Yeah.
Nanti slide-nya in English boleh?
Sorry, Prof.
The slide will be in English. Is that
It's okay because because all seminar mostly
it's
in
in English.
Yeah, because we invite the speaker from outside Indonesia, foreigner speakers. Yeah.
Aina, saya test saya punya slide sekejap.
Oke, Prof. Wait. Oke. Can, Prof?
Yeah, let me try first. Do you see it?
Yes, but not in the slide. So yeah, okay, very good.
So I stop sharing first?
Yeah, Prof.
Yeah, okay.
Langsung dimulai sekarang, Bu
Ya,
Aina.
silakan Mbak Rismi.
Oke. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon and welcome to DCSE seminar number 10 with the topic of When Machines See and Think, AI from Images to Smart Ecosystem. This seminar is organized by the Intelligent Research Laboratory, Department of Computer Science and Electronics, Universitas Gadjah Mada. My name is Rismi, and it is my great honor to serve as the Master of Ceremony for this seminar. First of all, before we begin, on behalf of the organizing committee, we would like to extend our warmest gratitude to our distinguished speaker, Professor Dr. Siti Zaitun Muhammad Hashim, and also Professor Dr. Azlan bin Muhammad Zain, both from the Faculty of Computing, University Technology, Malaysia. We would like to also express our appreciation to all participants who have joined us today in this seminar. Before we start, allow me to read through the agenda for today's sessions. First of all, we will have the opening sessions followed by group photo sessions, and then we move on to the main session and finally the closing session of this seminar. Now, let us begin this seminar by praying according to our own faith and belief, and I will represent the Muslim participant by saying Bismillahirrahmanirrahim. Okay, thank you. I think now the seminar is officially opened. And before we move on to the main sessions, we will have short group photo sessions. And for this session, we kindly ask all participants to turn on their camera and maybe can give your best smile and best pose. Okay, I will give you for 30 minutes to prepare. Okay.
Recording in progress.
Yeah. Okay. I think mostly everyone is ready. I will start taking pictures from page 1. Yeah, we don't know in which page you are in, so just keep smiling, okay? I will count 1, 2, 3. So please smile. 1, 2, 3. Okay, wait. Okay, let me save first. Okay, for second page maybe. Okay, 1, 1, 2, 3. Okay, I think that's enough. Thank you, everyone. You may turn off your camera now. Okay, now we will move on to the main agenda, which is the main speaker sessions. And to guide these sessions, it is my great honor to introduce our moderator, Mr. Oscar Nathan, PhD. Mr. Oscar Nathan, PhD is lecturer in Department of Computer Science and Electronics, Universitas Gadjah Mada. And today, Mr. Oscar will guide us in today's session and also lead the discussion with the distinguished speakers. So, ladies and gentlemen, now let us welcome Mr. Oscar Nathan. Mr. Oscar, the stage is yours.
Yes, thank you, Mbak Rismiati. Can you hear me? Can anyone hear my voice?
Yeah, clear
Right.
and sound.
Yes, thank you very much. All right, hello everyone. This is our 10th DCSE seminar. So for today's session, we will have two distinguished speakers from Malaysia, Prof. Siti Zaiton and Prof. Aslan. Yes, arrived. Thank you very much for coming here, Prof. Siti and Prof. Aslan. And also, thank you to Aina, yes, for the hosting the DCSE seminar. Right. So before we start, I'd like to introduce to you our speaker. For the first session, we will have a lecture from Prof. Siti Zaiton. So she is a professor in AI at the Faculty of Computing, UTM, University Technology Malaysia. She obtained her PhD in Computer Science from University of Hartford, US. And she also obtained her MSc and PhD from the UK, MSc in Computing from the University of Bradford, and PhD in Soft Computing from the University of Sheffield. Her research interests encompass AI, soft computing, machine learning, and data analytics. So to date, she has authored and co-authored over 100 publications in internationally reputable journal and conference. And yes, up to date, she also have supervised and co-supervised more than 40 PhD and master students to completion. So thank you very much, Prof. Siti Zaiton. So you can just start your lecture. And yes, for this session, the first session, Prof. Siti will deliver her presentations, and then we will follow up with question and answer thereafter. Okay. Right. Okay, Prof. Siti, it's yours. Sorry, Prof. Siti. I think you have to turn on the microphone.
Oh yeah, okay. Okay, is the display okay?
Yes, it's clearly.
Yeah. Let me just adjust this. Okay, so thank you to our moderator, Mr. Oscar Nathan, yeah? And respected Dr. Rismiati, and of course Dr. Aina for being the moderating this this event, and for contacting and inviting me, and respected docent lecturers from University Gadjah Mada, and also all dear students. Okay, so thank you again for inviting me to have some sharing with everyone. So the topic today will be Seeing Beyond Pixels, How AI is Transforming Image Processing Research. Okay, so basically what we are going to share today, you can actually remind me of the time, Dr. Oscar.
Yes.
Okay, so basically today we are going to see what and how actually AI has transformed the area of image processing research and also industries, and how it moved from the classical to AI-driven image processing, and what are the techniques, the algorithms behind image processing that eventually, goes into computer vision, and what are the applications that we are likely to see and to be part of it, and the opportunities, the challenges, and the future directions. Okay, maybe just like 1 minute or so to introduce UTM, even though Aina is our alumni, but probably some of you have not heard or come to UTM. So UTM has 3 different campuses, Johor Bahru, Pagoh, and Kuala Lumpur. So we are actually based in the main campus in Johor Bahru. It's half an hour from Singapore. And of course, the strategic one is the Kuala Lumpur branch, is the city of Malaysia. Okay, the numbers of students that we have, basically, of course, it's increasing, but right now we have 30,000 students altogether, with 4,800 plus lecturers. And the total alumni is basically 250,000 plus. So I believe that Dr. Aina is one of them, and I'm sure there are many more. So we would like to have this collaboration to proceed, to continue in many different ways between UTM and Gajah Mada. And of course, Prof. Azlan and me are proud to mention that UTM has been ranked at 153 in the QS ranking, and 164 in the Times Higher Education ranking. And out of that, we also have been awarded as the top 200 subjects ranked throughout across the faculties in UTM. And for our faculty alone, we have 2 subjects that are actually ranked the top 100 in the world by WUR, World University Ranking. So we hope that there will be more recognitions to be received by UTM, and probably by having collaboration with Gajah Mada, we can make this a reality. Okay, maybe to start with, I'm sure everyone here is already familiar and well-versed of the subject matter of AI. But maybe to start with, we can see what actually is artificial intelligence. So many people can come up with many different definitions. And of course, when it says artificially, it is actually an intelligence that is designed, brought into artificially, from how the human, as an intelligent human, sees, works, or make decision. So that intelligence is actually being transformed into a system, a program, and so on, artificially by us, by computer scientists, by people who are expert and well-versed of development of the system, intelligence system. So when we say AI is actually referring to the intelligence of human experts. So we can imagine we have so many brains, the expert, the good brains combined into one system. So of course we expect that the decision must be tremendous, must be very precise, or almost accurate. So it is the ability of how we turn the machine to be able to perform any job, any task that normally requires the experts, human experts, to make a very good decision. So we are now transforming that into a machine. That's why you are used to hear the word learn, training. So those are what the human normally do when they want to become an expert in everything. They have to do a lot of training, a lot of exercise, a lot of trial and error until they come up to the best performance, the best formula, the best model that it can be developed. Okay. So just to go through the evolution of AI. It started a long time before, right? I'm sure everyone is familiar, and in fact, Dr. Aina did, her PhD under my supervision. It was like years ago, and we can see that AI has been coined in as early as 1950s. It's not something very strange to many people, but of course the evolution has changed, and it becomes better and better in terms of the algorithm, in terms of the hardware, then it makes the solution much better, and almost like how the expert make a decision. Yeah. So of course you can have the slide later, and you can see all this definition and everything. So the evolution shows that it keeps changing to the better one. Yeah, from AI, we are introduced to machine learning, and we have algorithm that is able to learn and recognize the pattern, the behavior of the situation, and be able to make a decision when we provide a new situation, a new case study, a new problem. And then it comes to the level of where the advancement of the algorithm has changed from machine learning to deep learning. Okay? So it has this ability to grab, to understand, to interpret the high level features of any data or any object that is being presented to the algorithm. Yeah. But of course, looking at the name, deep, of course, the learning requires millions of data. Yeah, it requires a very high-end devices, platform, and so this thing will actually come along with the advancement of the algorithm. Okay, and now we are so familiar with the Gen AI, generative AI, where it is almost like how we deal with a human. Sometimes when you talk to your ChatGPT, for example, you talk to your Gemini, you talk to your Copilot, it's so personalized that you feel like you are talking to a buddy, to a friend that knows you so well, knows you, that you are a student, you are a computer science student in Gajah Mada, and you are like this, and so on and so forth. So this has become to the level that the algorithm is much, much more intelligent. Yeah. So now back to the title. So we see that with this development, almost everything that we see around us comes in image. Yeah, visual. We see them, we look at them, and how people actually perceive the image has triggered how this AI has transformed the image processing areas into something, that we almost, it is almost unbelievable. It is very much like how the human actually interprets. Okay? And we see maybe traditionally it can interpret the image, but in a very plain way, and it's not based on the context. Okay? But now it's able to interpret. Okay? For example, when the image of a patient being scanned, in the hospital, for example, it's like an expert is looking at that image. It will actually interpret that this patient is having this disease at this stage, with this, chronic situation, and so on. It's able to go, beyond what has been done before. Yeah, and so this is where the visual intelligence has actually being part of this solution nowadays. So we see that there is a paradigm shift. Yeah, how AI has changed everything with the introduction and the birth of deep learning. It has enabled machine to be like, sometimes we feel like it's much smarter than human. Yeah, it cannot just see, understand the image. It can actually interpret, and it can actually elaborate. It can make a decision. It can give a suggestion. Yeah, and of course, the thing behind it is having very large data set that allow this machine, the system to understand, to be able to interpret every single pixel of the data we can see. So we can imagine it's so large, and of course it requires so many special and different ability of the hardware. And from here we see that now the solutions have become more automated. Everything is so at our fingerprint. We can actually give an image to the system, or maybe we talk about generative AI. We give an image of, let's say you get a printout of image given by your doctor about your disease. You can actually upload that at ChatGPT, and you ask to explain, elaborate what it means and how severe it is, or what is the condition. Then it will be able to explain, and surprisingly, the way it explains is like your medical doctor explains to you. So it's like very miraculously implemented by the very advanced algorithm. So if we see the evolution of this algorithm transforming the image processing areas or research, we see that from the traditional way of solving problem, we do we still do some filtering, how we segment our data, our image, and we have to find the thresholding and so on. And then we see that how it starts to change. Like I showed you just now, to machine learning, to deep learning, to generative AI. So we see how the process has actually changed, and new terms start to be coined in. Before this, we have to understand the features. We have to identify what this is. This is what, this is what, this is what, this is eye, this is nose, and so on. But when it comes to deep learning, it will actually understand the whole feature. So it has the feature engineering, the feature extraction that can be automatically done with the ability of the algorithm. And what more now with the generative AI, it can actually synthesize, and it can give you very detailed elaboration of what the image is about. So that is the evolution that is taken place. And we can see that it has changed actually from the quite semi auto or manual, for example, from rule based to data driven. So now actually data is the key. So when you have data, when your data is actually representing the right problem, then it's like opening ways for you to manipulate or to get benefit from this advancement of AI in image processing. So we see that how the techniques has actually changed from time to time. And if, like say, the students, you are looking for room of research, what kind of problems that you want to solve. When you deal with image, there are so many things that you can do. So we see there are terms that you might see. For example, there are algorithms under deep learning. It is called CNN. It's called VIT. It's called GANs. It's called SAM, segment anything. And now we have the HAI based solution, where it is actually locally processed, and it allows us to do a real-time, image processing, to make it faster, and of course to solve the very real problem. So it's like when we get an input, we as a human, when we see one input with the knowledge that we have back in our head and also from our experience, we can actually interpret. But we can imagine how if, let's say, someone has not seen the image before, he has no clue what that is. But now, with the existence of deep learning, algorithm and also the ability of so many advanced in the the transformation of the solution. We can actually, for example, if you want to check what kind of cat that you have, so you upload the image on ChatGPT, for example, then you can say, okay, explain about this cat. Then it will give you like a very long list of explanation. What is what do you call that? The maybe the kind of the name of the not genetic, what do you call that? The type of cat it is, and how where it comes from and what is the age, whatever, you can see a long list of explanation. So that has been made possible by this computer vision with the deep learning algorithm. So basically the transformation that has been done by the existence of deep learning is it is we can say simplify. Okay, before this, when we apply machine learning or maybe rule based, we need to identify what are the features of the image. We need to label in detail. Then we need to put what is the label to classify what this is, that is, before the system or the algorithm is able to recognize the image. But right now, with the existence of deep learning and so many different kinds of deep learning algorithm, it's actually make things faster, because it is like merging the stages, of extracting the feature, classifying them, and all in one. Yeah, so it is actually make things not simpler, I would say faster in terms of the data, the processing the data. Okay. All right, so I just give some basic steps that if you want to see how actually this algorithm works. Okay, so we need to have the images, we need to make the algorithm learn, and we need to do some training, and actually what happened in between is there will be some parameters that will be adjusted, by the algorithm, and it is done so many times, thousands, 100,000 and so on, until it gets to the very most accurate answer, of what this image is actually. So that's why it is able to recognize, even though we provide after that a new image of different kind of cats or dogs or whatever, it is able to actually classify, and is able to explain further, with this existence of the algorithm. Okay, if let's say you want to give a try, or to play around of how actually this machine learning or deep learning works, Google has provided this. It's called Teachable Machine. Okay, so it's like no code experiment. You don't have to know exactly what are the command line by line, just to give you a flavor of how actually the machine learning or deep learning works. Okay, so for example, let's say I want to see whether I can train a model, I can develop a model that can recognize two person. Okay, so this is me, and this is my friend Anazida. Okay, Prof. Aslan knows this, and probably Dr. Aina also knows. Okay, so what we have to do is we need to find some images of the object. For example, I just found some pictures of me from internet, 4 of them. So I upload on this Teachable Machine platform to teach the algorithm that these are the pictures of Siti Zaitun. Okay, and then I find another pictures of my friend, my colleague Nazida from internet. I found 4 of them. So I upload them on this platform, and I train them I label them. It's like labeling. So I label them. These are the pictures or the images of Anazida. Okay. So now we have two set of data, and then next we can actually trigger the training move by we can actually select a different algorithm. So I just take the default one. Okay. So it is training to match to adjust the weight and the algorithm so that it knows these are the pictures of Siti Zaitun and this is the picture of Anazida. Okay, so it will like train the algorithm, and then now when it's done, we want to test them. Okay, so we want to test them. So we find another picture. So I search from the internet another picture of me, then I just upload on the platform. It's like we are asking the system. So who is this? Who is this? And then from that, we see that the model that is being trained just now has decided that this is a picture of Siti Zaitun, which is true. Okay, and then I find another picture of Anazida, which is not among the data that we train. Okay, I found another one. she went for her Hajj. Okay, and then we upload on the platform. Then it's like we want the algorithm to identify who is this. Okay, and it seems that the model is able to identify that this is very close to the images of Anazida. Okay, so this is the concept of how we train the algorithm to understand and to be able to identify the object. Okay, so when we come up with a new data or a new image, the algorithm is supposed to able to detect or to identify what the image that we present later to the system. Okay, so that's a very just like a simple experiment for those who want to have a go on how actually it works. Okay, so we see many applications of deep learning in computer vision or in image processing. Okay, so computer vision is like the advance of image processing, how it has utilized the deep learning and also all the advance in algorithm. So of course we see that in OCR, it has utilized and manipulated and has benefited from image processing with AI process, where it helps so many different applications. Okay, for example, for blind people, they are able to, for example, to enter certain area where they can just like use this kind of OCR without having to be able to read and so on. So it's like it opens up so many solutions to so many different people and so many different applications. Okay, and we see also the advancement of image processing and computer vision in terms of the labeling and identifying or detecting the image. Okay, so it is able to detect many images or objects at the same time. Okay, so this is a great advancement of the algorithm of AI in image processing. Sorry. Okay. And what else? Okay, we see that people who are working with images, for example, sometimes we want to get rid of the background, so we are able to do that now. Yeah, it is like it's very automated, simple process that we can do with the help of this algorithm. And of course, another area that actually benefits from AI and computer vision is the medical, where so many advancement has been done, for example, to detect the kind of disease of certain patient as early as at a very early stage, and it helps it helps the patient to survive. Okay, so how the algorithm has managed to enhance the image. And sometimes if like say the image is not clear, with some noise, with some blurry, the algorithm has managed to make it clearer, increase the resolution, and until the expert or the system is able to identify, the right spot, and is able to make a good decision of detecting what is the disease of the patient. And of course, talking about face detection and recognition, we have it on our handphone, and it's supposed, or is able to detect, we can have it as a secure way of entering, accessing your password, your system, by just using your face. Yeah, so it's like very advanced solution that is provided in the biometric authentication and so on. Okay, and also in the recognizing the logo and brand. See, I'm just giving this idea so that maybe if, like, say, students are looking for, area of research, you see there are so many things that you can do with the local data, with the new data. Okay, so brand and logo recognition also has benefited from this, where not just it can detect the logo that is very unique to certain identity or industry, or company. It also can detect, for example, if someone is trying to use the logo, unauthorized, try to do some, mischieving action and so on. So the algorithm can, provide us a way of solving this. Yeah? And it can also be aiding or helping us in terms of identifying there are sometimes, for example, the images, we need to do some moderation. We need to protect because of certain reason and whatever. So this actually can be done, of course, for safety. Okay? But for everything, there's always the positive and the negative side. Yeah? Maybe the intention is good, but there are also people that will, take it for the bad purpose and so on. Okay? So this information masking can be done, to protect the image of the object and so on. Okay. Also, we see that using the generative AI, like I mentioned before, you can do so many different things, right? You can actually generate a new image that you do not even think of. Yeah? You just give a prompt and suddenly it gives you like more than what you expect. So it is actually a great transformation from how the image, that first trying to understand the image. Now it goes to another level. Generative AI helps, with the help of AI, deep learning, and so many advanced algorithms. It helps to imagine new image. Yeah. So it's like going to another different level. Yeah. Not just able to understand, to interpret, but it can create a new one. Yeah. So that is actually, very how things have changed so fast. And okay, the last word is, of course, that remind us, the term ethical, how we need to be responsible of what we do. And people can manipulate this, in so many different ways. Okay, so just to share with you some research that we have implemented in university, and of course with our students, PhD student master research, and of course we look forward to have this exchange of ideas and so on. And we see that how AI has been used to do detection of so many different applications. Yeah, one of them is disease detection. And of course, we can imagine how this can help to save patients. And if we talk about, for example, breast cancer disease, we can imagine if, like, say, we have this, advanced algorithm that can help to detect, like years before, the potential of developing the cancer, we can imagine how the medical people can help, the patients, the women, from having to go through, all this painful treatment and so on. So all this advancement actually helps the life of many, people out there. Yeah. So one of the research that has been done by our student is to help diagnose leukemia based on the images of white blood cell. Yeah, so it's trying to detect the look and it tried to interpret the image of the white blood cell. So from there, it will link to whether it is related or it helps to identify the possibility of having, this leukemia. Okay. And another one is also done by our student. He was like trying to see whether giving two images of, pictures, for example, father and son, mother and daughter, mother and son, husband and wife, can we use the algorithm, the deep learning algorithm, to identify whether they are actually related? The kinship verification. We are trying to verify that. And it's not very successful, like 80% accurate, but it is more than 50% because we are still lacking of data, the correct data, the reliable data. But it is quite interesting research that we want to see if, like, say, maybe your face and your mother, can be detected by the algorithm that says that, oh, you are 90% related. And to go to the next level, you are mother and daughter, for example, mother and son, and so on. So another research is about how we try to help, the people with these disabilities that use hand gestures. So we try to, even though it is already in, the commercial ones, but we try to see how the algorithm can be further enhanced to give a better, accurate interpretation of the signs that is used by both hand, and it can be like, real time and with a different background. So this create a very real application, and it can help certain group of people that really needs this. And another one is how we try to detect what do you call that, diabetic patients by looking at the image of the eyes. So this is another research. All these are about image processing related research. And this one is about how we use the face and also the fingerprint together as the multi-models. We combine inputs, more than one, to see whether it can further enhance the authorization, the authentication. And of course, we see that nowadays the drones have been used everywhere in many different applications, and the function of drone is to take images, and that image need to be processed, to be detected, to be classified. So one of the research done by our student is we use drone to detect the different cracks of roads, and it will capture the images, and it will be interpreted as defect of the road, and the next level is what kind of defect. And from there, of course, the significance of it is we want to suggest to the authority that there are road defects, and these are the defects at this point, of the road. And of course, this is only the small scale of roads. We just try in UTM. Okay, and another research that is ongoing is how the students use the images from the satellite taking on the oceans of certain area, and that images reflect the pipelines of the what do you call that, the fuels, and it's trying to detect the oil spill. Yeah. That has like a broken pipe and everything. So that is based on the images. Yeah. And also, the one that we are actually doing now is trying to take many real-time pictures of the rice paddy fields, to identify or to detect what kind of disease that actually being affected by the leaves. And of course, the problem is that the challenges are the leaves are quite small. The paddy leaf is quite small and it's like overlapping. So how we can do it real time with the help of edge computing platform, we try to capture the image and try to detect that there's something wrong with the paddy leaf, and what kind of disease, and how we can actually suggest ways to improve that. Okay.
Prof. Siti, I'm sorry
Yeah.
to interrupt, but can we finish this presentation in like 5 minutes, because we want to have
Okay,
few
sure.
presentations thereafter.
Yeah.
Sorry.
Okay, fine. I just go fast. Okay,
Yep.
another I think one that we normally heard about is deepfake. How it actually being misused. The images. Of course, there are positive and there are more negatives on that. There's something that people are now investigating of how to actually find out whether this image is fake or not. Okay, so probably many lecturers are looking for areas to study. That can be one of them. So we can see there are many future trends. How the AI can be used with the AR, VR, and the edge processing that I mentioned can help the real-time application because it's faster, it is local saved data and so on. And of course, one thing that we need to remember is how we can actually use the AI in a very responsible way, how to make sure that it is responsible enough. Yeah. So I think that's about that we want to share, and we see that the move of this is it helps to improve in terms of the faster experimentation of the research, and it can go across discipline, and it can actually advance the image processing area, and it helps so many different industries. Yeah. And like I mentioned, the responsible AI, we can go another level where the explainable AI can be applied to reason out how the decision is actually made. And okay, last but not least, I would like to highlight this. We know that AI has made a big impact to everyone in the world. It's supposed to bring good, but of course, there are always people that will manipulate this, for the bad, and this is one of them. And we know that, with our heart, we pray that our friends in Palestine will be safe. But it is already there, and it's being discussed how AI has made it worse. Even though it's go for precise result and decision. Okay, so I think with that, I would like to end the sharing, and I hope that everyone has gained something. And okay, thank you very much. Back to the moderator.
Right. Okay. Thank you very much, Prof, for your presentations. Very, very interesting, and yes, very insightful for us. Yeah. So, as I said before, we will go for the Q&A session. So, I'd like to invite the audience if you have any questions or any discussion regarding the Prof Siti's presentations, but how AI transform into image processing and computer visions, I believe. Okay. Does anyone has questions or any discussions? you can microphone and directly ask her, or you can put your questions in the chat column, and I will read it to everyone. Yes, we have a question from Mas Bintang Arya.
Thank you very much for Dr. Oscar for the chance, and good afternoon, Professor Siti. Thank you very much for your insightful session. It's really interesting when we talk about image processing, because I have experience when I try to analyzing an image. Let's we talk about ChatGPT, for example, and we want to analyze the image. And surprisingly, the ChatGPT is, I think it's easier to understand the image rather than the text, the contextual text. So based on your explanation, what the ChatGPT see in the pixel level really easier to understand than contextual what I mean, like that. And my question is regarding the current implementation of generative image. I mean, the model for generative image. Some days ago, I read some paper, and in this paper, the researcher used the generative image to augment an image as additional data set for the process. So what is your perspective regarding this kind of process? Because I think when we add generative data to real data set, it's kind of combining some fake information with the real world information. So what is regarding this kind of cases? Thank you.
Okay. I answer directly or wait for another one?
Yes, I think you can.
Okay, I can respond. Okay, thank you, Mr. Bintang Arya. You are a lecturer there? You are a lecturer? Docent?
No, I'm a PhD student. This is my
Oh,
first year.
PhD student. Okay,
Yeah,
okay,
this is
okay.
only my
All
first year.
right.
Thank you.
Okay. Yeah. When we do research, involving image, of course, I think one of the problems that we normally have is we don't have enough data, or maybe the data that we have does not represent the full, picture or the full behavior of the image. So we need to augment them, and actually we also do that. We do augmentation because we need to have more data from different angle, different contexts and so on. But now it seems that when we do research and when we want to submit a journal even, they will ask for some ethic, like approval, from the committee. So one of them that will be checked is the data that we use. So I think maybe that is one of the, to make sure that we do not violate the rules of creating a new data. Not really new data, but still we consider new because it is being augmented, right? Okay, I think that's my take on that.
Thank you, Professor Siti. Maybe I adding more context regarding my case before. I read the paper about the detection of droplets in agriculture, and the researcher, the author, detected around 1,000 images, and because it's a small data set, they using kind Halo AI to generate new image. So the original image it's not an enhancement, I think, because if it an enhancement, it should we can see it by like it still look like a real world image, but it looked like a cartoon. I mean like generated image. So that's why this is a key one paper. So I just considering how they consider this kind of scenario for making a new additional dataset using generative. So the dataset become around 10 times from the original, I think, if I'm not wrong.
Right. Okay. I'm not sure. Honestly, I'm not aware of how much or until what level, to the extent that we can augment that, even like from the real image to like cartoon look images, whether it is acceptable or not. But if, let's say, for PhD examination, we as the examiners, of course, we have to interrogate that. We need to make sure that does it represent the real situation, the real context? How do you validate those data? Who are the experts? So I think those are the things that you need to look into to make sure that the data that you bring, to define your thesis, must be truly, and correctly created or developed. Okay,
Okay,
thank you.
Professor.
Thank you, Mas Bintang and Prof. Siti for the discussions. Very nice. Actually, it's kind of explanation using generative AI for computer vision things, right? Okay.